Hello everyone, welcome. This is your 7th chapter, Distributed Objects. Message passing versus distributed objects. Message passing paradigm is an appropriate paradigm for network services where processes interact with each other through the exchange of messages. So, in message passing paradigm is a basic paradigm. Here the processes interact with each other through the exchange of messages. So, but the abstraction provided by this paradigm may meet the needs of some complex network applications for the following reasons. First one, basic message passing requires that the participating processes be tightly coupled. That means they should be interconnected tightly. So, throughout their interaction, the processes must be in direct communication with each other. If communication is lost between the processes, the collaboration fails. As an example, consider a session of the echo protocol. If the communication between the client and the server is disrupted, the session cannot continue. So, here this basic message passing paradigm requires the participating processes must be tightly interconnected. So, if there is any failure in connection, the communication will fail. So, the message passing paradigm is a data oriented. Each message contains data marshaled in a mutually agreed upon format. So, this data is marshaled in that means it is encrypted. It will be in some in a mutually agreed format, and each message is interpreted as a request or a response according to the protocol. The receiving of each message triggers an action in the receiving process. So, here message passing paradigm is data oriented. So, data or message is sent or received. So, for example, in echo protocol, the receiving of message from process P elicits in the echo server this action. So, take an example of echo protocol. The receiving of a message from process P. So, echo protocol receives a message, echo server receives message from a process P. So, this will trigger action in a echo server, that is a message containing the same data sent to P. So, server will send a data to P, okay, process P. In the same protocol, the receiving of a message from echo server by process P triggers this action. A new message is solicited from the user and the message is sent to the echo server. So, after receiving the message from echo server, the process P will trigger this action. That means there may be a new message will be requested from the user and the message is sent to the echo server. So, the action is performed at both sides, process P and at the server side. So, at the server side, the message will be sent to, the action is message will be sent to process P, and at the receiver's end the action is performed. The action is the new message is requested from the user and the message is sent to the echo server. So, the data orientation of paradigm is appropriate for network services and simple network applications. It is inadequate for complex applications involving a large mix of requests and responses. So, here message passing paradigm is data oriented, and this data oriented is just appropriate for some simple network applications, and it is not suitable for the complex applications involving a large mix of request and responses. So, in such an application, the task of interpreting the messages can become overwhelming. Okay. The distributed object paradigm is a paradigm that provides the abstraction beyond those of the message passing model. See here, this message passing model is just a basic model and it is not enough, it is not inadequate for such complex applications, but for that we have a distributed object paradigm, and its name, as its name implies, the paradigm is based on objects that exist in a distributed system. In object-oriented programming, supported by an object-oriented programming language such as Java, objects are used to represent an entity. So here, in a distributed object paradigm, it is highly object-oriented, and objects are used to represent an entity, and that is significant to an application. Each object encapsulates. So each object contains a state or data and the operations. The state or data of the entity. In Java, such data is contained in the instance variables of each object. The operations of entity, through which the state of the entity can accessed or updated. In Java, these are the methods. Okay, so each object contains the state or data of entity and operations. So operations are methods, and state or data, that is the instance of instance variables. So here, archetypal distributed object architecture. This is the diagram of archetypal distributed object system. A distributed object is provided or exported by a process called object server. Okay, the distributed object is provided or exported by a process. So here, in distributed object architecture, there is a distributed object provided by object server. So object server will provide distributed object. A facility, here called an object registry or registry for short, must be present in the system architecture in order for the distributed object be registered. Okay, so here the object registry is provided, and the object server will register its objects in object registry. So to access the distributed object, a process, the object client, looks up the registry for a reference to the object. So this reference is used by the object client to make calls to the methods of remote object or remote methods. Logically, the object client makes a call directly to a remote method. In reality, the call is handled by a software component called a client proxy, which interacts with the software on the client host to provide the runtime support for the distributed object system. The runtime support is responsible for the inter-process communication needed to transmit the call to the remote host, including the marshalling of argument data that needs to be transmitted to the remote object. So here we have a process, object client. It looks up the registry for a reference to the object. So this reference is used by the object client to make calls to the methods of remote object or remote methods. Okay, so the object client makes a direct call to remote method, and in reality the call is handled by the software component called a client proxy, and it interacts with the software on the client host to provide the runtime support for the distributed object system. Okay, see here the object client, it looks up the object registry for the objects or for the reference of object. So it will get, the client will get a reference to the distributed object. Okay, and this, see here the logical data path, and this is physical data path. So here logical data path from object client to object server. Actually, object client makes a direct call to object server, that is logically it is a direct call, but in reality there is a software component, the client proxy. So this is the client proxy. So object client will make use of client proxy to make the method call. Okay, so this object client proxy, the client to make calls to the methods of remote object or remote methods. The object client makes a call directly to a remote method. So in reality the call is handled by the software component called a client proxy. So it interacts with the software on the client host to provide runtime support. Okay, so it interacts with the software on the client host to provide the runtime support. See here, the object client makes a direct call to object server, and actually there is a software component, and this call is handled by the software component, this client proxy. Okay, so it interacts with the software on the client host to provide runtime support. So it client proxy, it provides the runtime support, and the runtime support is responsible for the inter-process communication needed to transmit the call to the remote host. So this runtime support is responsible for the inter-process communication. The inter-process communication, that is the transmitting the call to the remote host, including, so here the call is transmitted to the remote host by runtime support with the network support. Okay, so this runtime support is responsible for transmitting call to the remote host. So the call contains the argument or data, that is arguments, the marshalling of arguments. So here it will marshal the data. Marshalling means it will convert it to some marshaled format, some other format, that is so network, it will be marshaled format, and so that needs to be transmitted to remote object. Okay, so here the client proxy and with the runtime support. So the runtime support is responsible for inter-process communication. So it will transfer the call to the remote host. The call contains the argument, that is marshaled arguments. Okay, so a similar architecture is required on the server side, where the runtime support for distributed object system handles the receiving of messages and unmarshalling of data, and forwards the call to a software component called the server proxy. The server proxy interfaces with the distributed object to invoke the call method call locally, passing in the unmarshaled data for the arguments. The method call triggers the performance of some task on the server host. The outcome of execution of the method, including the marshaled data for the return value, is forwarded by the server proxy to the client proxy via the runtime support and network support on both the sides. Okay, so the similar architecture is required at server side. See, so this is at the client side and this is server side. So the similar architecture is required at the server side. So the runtime support for distributed object system handles the receiving of messages and unmarshalling of data. So the runtime support at server side, it handles the receiving of messages. So here it will receive message from the client. Okay, the runtime support of server server side, it handles the receiving of message and it will unmarshal the data. So here at client side runtime support, it transmitted the marshaled data to the server, and the marshaled data is unmarshaled here at the runtime support. Okay, the runtime support for the distributed object system handles the receiving of messages and the unmarshalling of data, and forwards the call to software component called the server proxy. So this runtime support, it will transfer the call to the server proxy, and the server proxy interfaces with the distributed object to invoke the method call locally. So this is the object server, and this server proxy will contact this object server and it will for the method call. Okay, the server proxy interfaces with the distributed object to invoke the method call locally. So here the method call is done, the method is called locally, passing the unmarshalled data for arguments. So the method call with the arguments are unmarshalled data. So the runtime support of server side has already unmarshalled the data, and that is sent to the object server with the method call as arguments. So the method call triggers the performance of some task on the server host. The outcome of the execution of the method, including the marshaled data for the return value, is forwarded by server proxy. So here the object server, the method call will trigger some action and it will get the return value. Okay, so here the task is performed and it will get the return value, and the value is marshaled, and that marshaled data is data for the return value. So the is forwarded by server proxy to client proxy. So this, the marshal data, the return value, is sent to the client proxy. The server proxy will send the return value to client proxy with the help of runtime support and the network support of server host. Okay, so the forwarded by the server proxy to client proxy via the runtime support and network support on both sides. Okay, so it will make use of runtime support. Actually, this runtime support is responsible for inter-process communication. So the server proxy will send the return value to the client proxy. Okay, so this is the archetypal distributed object architecture. So now the distributed object systems, the distributed object paradigm has been widely adopted in distributed applications, for which a large number of toolkits based on the paradigm are available. Among the most well known of such toolkits are, so distributed object systems tool. So these are all the toolkits for distributed object systems, and this question is important. And so the toolkits are RMI, Corba, DCOM and SOAP. Okay, RMI, Corba, DCOM, SOAP. RMI is Java remote method invocation, common object request broker architecture, that is Corba, the distributed component object model, that is DCOM, the simple object access protocol, SOAP. Okay, simple object access protocol, SOAP. So these four toolkits are widely used for distributed object systems.